most of you probably know what CRISPR is. Basically, it's a bacterial defense system. It's an immune system in the bacteria. And it was found by mistake in 1987 by some Japanese scientists who were looking for something else. And they saw this weird group of nucleotides that they couldn't understand, and they didn't know what to do with. And so they wrote their article and published it in the Journal of Bacteriology. And literally in the last sentence, they said, and we saw this weird formulation. We have no idea what it does biologically. And that was it. And that was it for a really long time because no one else could understand it either. Then it started popping up, and other people saw it and started to wonder what it was. And the idea is you cut out the bad things, you replace them with good things, and we're all happy. It's, as you'll see, perhaps more complicated than that, but it is a remarkable achievement, and so far it works beautifully in labs. How soon will we see clinical trials that involve CRISPR to kind of circle cancer mutations so that we figure out ways to cut them out or stop them from working? Is that going to happen in 2 years or 5 years or 10 years?
I think we're making a lot of progress already. Just one really powerful example of a CRISPR application is that we can study genes and identify genes at much higher speed. So one experiment you can do is you can take a cancer cell line, and we know that cancer cell line, if you give it in a patient, if you give a patient a cancer drug, over time they'll become resistant to the drug, and so tumors will come back and the drug won't work anymore. An experiment we can do now using CRISPR is we can take the same tumor cells, use CRISPR to mutate every single gene in the genome systematically and comprehensively within a matter of 1 week, and then put a drug on, and then see what are the genes when mutated will make the cell resist the drug, so make the tumor grow again. And so we can do this by turning genes off, or we can do it by turning genes on using CRISPR. And this kind of new type of experiment will allow us to generate an encyclopedia of what in cancer type A, what are the mutations that make a drug resistant, in tumor type B, what kind of drug, and so forth. And that will really change the way that we treat cancer in the future.